For a long time, I've had an ambition to get on the QO-100 satellite, pretty much ever since it's been up there, and I was able to go on to that British Amateur Television Club SDR that lets you tune through the narrowband transponder, which is actually, it's only based, that SDR, a few miles from where we're sitting at the moment at Goonhilly in Cornwall. And I've listened to it and thought, that's fantastic. I'd really love to get onto that satellite, but how to do it? And I've looked at all the different ways, and there's quite a lot of ways that you can put together your own station quite economically. But I was trying to think of a way that I could do it as tidily and as easily as possible to have a station that I could set up at home, but I could also take out with me portable if I want to. And that's when I found out about the DX Patrol Groundstation 2. Now, on their website, they've been supplying for quite some time. They're a company based in Portugal, and they've been supplying various bits of equipment, up converters, down converters, LMBs ready to go, and helical transmit antennas, and various bits and bobs to help you to put together a station. They then came up with an all-in-one box solution, which was the DX Patrol Groundstation. But that wasn't full duplex. So now they have introduced the Groundstation 2, which is full duplex, which means that you can listen to the downlink at the same time as you're transmitting. Obviously, you need two radios to do that, or a radio that works in full duplex, like the IC9700, and away you go. All in one box, all neat and tidy, and for reasons that will become clear later, it's going to go down with the senior station management here a little bit better if it's a tidy setup. So let's have a look at the ground station. This is the DX Patrol Groundstation 2, and we'll see it in action in a bit, but I just thought I would show you the controls. It's very straightforward on the front panel here, not a lot, just the on and off switch, and this knob here, which will scroll us through the menus when we're switched on, and the display on the front. Now, as you can see, we've got a lot of connectors on the back here, and that's because of what this box of tricks does, because it's got to take an input for transverting up to 2.4 gigs, and it's got to take receive from an LMB on the satellite dish to transpose down to whatever frequency you're going to be listening to on your receiver, and it's also got to put the 2.4 gigs that's been converted from whatever you're using as your driver up to the dish for transmission, and also it has to have a GPS antenna connected to it. So these are all the connections here, starting with the power connector here. So it's 12 through 24 volts that you can supply this on, any voltage between 12 and 24. And at 12 volts, it needs your power supply to be up to about 5 amps. So you've got to be able to supply 5 amps for when it's on transmit. So we have two SMA connectors here, are for the IF transmit and receive, and IF receive only. Now this is really important because when you're operating in full duplex, you're going to use both of these. So this one is okay to transmit up because at 500 milliwatts of TX power into it, it will switch the receiver out and switch into transmit. This one here is receive only. So when you're working in full duplex, the way I'm going to connect this up, I'm going to have my 2 meters going into here, which is going to be converted up to the 2.4 gigs. And I'm going to have my SDR receiver connected to this one, listening to the downlink. If you accidentally transmit into this one, you're going to kill the box. So you just don't want to do that. Now, if you weren't operating in duplex, you could go transmit and receive just out of this one. That's fine, because when you hit 500 milliwatts of transmit power into here, the Vox kicks and it starts transmitting. Ideally, you want about 1 watt of drive. 5 is the absolute maximum, and that will give you about 10 watts out here, out of this end connector on 2.4 gigs. Now, we need 2 connections to our LMB, and as you can see, these are the standard F connectors that we use for our domestic satellite TV. And the reason there's 2 is because you use a modified LMB for satellite work, for satellite communication work through QO-100, because you need to stabilize. The LMBs that we use for satellite TV tend to wander about a bit in frequency. It doesn't matter really for a TV signal because it's so wideband. But when you're working with sideband, we need to be frequency accurate. So what you need to do is lock the LMB by sending it a nice reference frequency. So we've got 2, that's the signal. So that's the normal converted signal coming down from the LMB, and this one is sending the lock signal up to the LMB. How do we lock that signal going up to the LMB? Well, that's where this comes in. This connector is for a GPS antenna. And I note from the manual it says, you know, have the GPS antenna outside if you can. I have to say I've had quite good success with it indoors. If you get it near a window, or where I'm going to finally install it in my garage, I'm hoping I'll be able to still see through the garage roof plenty of satellites. We will find out, see if it works from there. So those are our connections. There's also one optional PTT rather than it working on the Vox. So if you want to actually control your transmit by switching it to transmit, you can do it through there, which, as I say, will take up to 500 milliwatts to trip that. You could have a manual PTT connected in here. And a couple of little pots on the back here. One is for the Vox delay, and the other one is receive sensitivity. You can turn the receive sensitivity up and down on the receiver. And they do say, DX Patrol, that the optimum drive is about 1 watt. So that's ideal. And that will give you the right output, which is 10 watts out on 2.4 gigs. So you can select your IF frequencies for transmit and receive, and I'll show you that a little bit later on. But basically from 10 meters right through to 1297 megs. You can pick a band in there for uplink and a band for your downlink, depending on what radios you're going to be using for that purpose. There we are. Those are the connections. So now we need to connect some cables to them, but we're not going to do that here in the shack because I've got a special place for this to live. It's a place that's close to my heart because it's where the beer lives. That's in my fridge, and this is going on top of the fridge in the garage. Before I set everything up on my main 1 meter offset dish, I thought I'd just show you the DX Patrol LMB that I'm going to use, and I've just set it up here on my portable dish before we put it up on the big dish so that you can see it. And it has, as we mentioned earlier, got 2 outputs on it. One of them is the signal output, which is the one that is going to give us the down converted signal from the satellite, down converted by the LMB. And actually I called this an output, it's actually an input, because this is the one where we're going to put the lock oscillator frequency up that comes from the ground station, which is really tightly locked to the GPS, which will keep the LMB nice and stable and make sure that we can resolve SSB signals without all kinds of wobbliness. So that's fine. We're going to have 2 leads coming down from the LMB going to the ground station too. But what about the transmit side of it? Well, DX Patrol used to make, and I think it's still available, their original helical antenna, which is this one, which is just 2 turns. And this would, you move these clamps off like this, tighten them up, and you just slot it over the LMB, then pull these around and tighten them up. And then you connect your 2.4 gigs cable to that end connector. But DX Patrol have now introduced a new helical antenna. So this is a 4-turn one, and it has this little sort of radome to go over the top of it. So we screw that on to give it its weather protection. Easier said than done. Hang on, I don't want to drop this because it is a little bit fragile. There we go. And it has adjustable clamps here which will hold it onto the LMB, and this just sits over the front of the LMB, and the connector here, which is where we're going to connect our 2.4 gigs cable to. So we simply place it over the LMB like so. If I can pull the clamps back far enough, it'll let me do it. Then we just push those clamps in and then tighten up the screws, and then we do the same on the other side. There we go, and then we just have to connect our 2.4 gigs cable, and that's how the LMB assembly and the helical antenna assembly are going to look when they're up on the big dish. I've already got an LNB on my 1 metre dish, and I keep the other one on my portable dish full time. So the LNB's there, ready to be connected up to the ground station. All I need to do now is go up the ladder and add this. Just before I do though, I want to tell you a little bit more about it, because the reason DX Patrol have developed this new 4-turn helical is because it's got more gain, and they reckon that you can use it with smaller dishes down to a 40 centimetre offset dish, and you can still get a good signal into the satellite as long as you've got enough power to go into it. So great if you're going to go portable like I'm going to with my caravan, or maybe for emergency comms or whatever, when a smaller dish is going to be easier than carting around the bigger dishes we used to need. As I've said, it's pretty easy to clamp it onto the LNB. I'm hoping that will be easy to do when I'm up a ladder. I would invite you to watch me, but just in case I fall off, I'll show it to you when it's done. We're getting near the moment of truth now, and the dish is up. We've got the helical antenna clipped over the LNB. The LNB is up, so we're all ready to go. And I know, what a devil our producer can be in terms of outtakes. So I thought we'd put it all up there and then start talking about it, rather than having endless outtakes of me falling off the ladder. So it's up there now, it's ready to go. And you'll notice we've got the 2 leads coming out of the LNB. As I told you, one of those is the synchronizing signal that's going to keep it nice and stable, and the other one is actually providing the downlink signal. So I've cunningly stuck a bit of green tape around one of them at each end, so I can identify which of the 2 leads are which when I come to connect them up to the ground station. And the ground station itself is in the garage, but my shack's not in the garage. So why have I done that? Well, because it's all about the cable length, because we can see also from the green helical antenna, we've got the end connector on the back, and we've got a fairly chunky cable coming out of that, which is for the 2.4 gigs from the ground station up to that antenna. And that's where you can have a lot of losses. And I realized that the cable run from where the dish is, and this is the only place I could put the dish, down into my shack, was going to be too long. So the solution to that is to put the ground station in the garage here. That makes a shorter cable run, particularly for that 2.4 gigs and for the LNB cables as well. And then from the ground station, 2 coax feeds down to my shack. One of those will give the 144 megs up from my Geostationary, which I'm using to drive the transmit transverter in the ground station, and the other cable taking the 432 downlink, which is going to my SDR radio in the shack. Here we are in the G0FGX garage. If this was a Zoom call, of course, I'd have a tropical island or something behind us. But as this is TV, I can't cover up the fact that this is my garage. Not the tidiest garage in the world, probably though not the most untidy garage in the world, but that's not what we're interested in. We're interested in what's on top of the freezer here, because that is the site that I've chosen for the ground station 2. And as I explained, that just means I keep my cables shorter to the dish and then run the RF cables down into the shack. So what we'll do first of all is switch this on, and you'll see what the ground station does in its boot up sequence. So first of all, we've got the splash screen. Then it sends a little bit of Morse code. I've got that switched on at the moment. That is an option, you can switch that off. But it's quite a neat little thing for anybody who's visually impaired, because it does tell you in Morse what's going on as you're adjusting the various settings and going through the menus. Now, what we're waiting for it to do, 2 things. As you can see at the moment, we've got wait and acquiring position. The GPS antenna, I've popped it just on the top of the ground station here, and it still will manage to acquire a good few satellites, and so it'll be able to work out where we are. So it's doing 2 things. You can see it's acquiring a position for us, and the other thing that it's doing is bringing the oven up to temperature that's got the crystal in it that's controlling the frequency here, so that's temperature controlled, because you really need pinpoint accuracy on the frequency. Otherwise you get some serious frequency excursions while you're transmitting, which will not make you friends with the rest of the users of QO-100. So it's very important you don't start transmitting until that wait on there changes to lock. So we're waiting to acquire our position, and we're waiting for it to lock up. When we were first getting ready to film this, our cameraman said, "Could you dust the dust off the front?" I said, "That's not dust, that's stars. Look, there's the satellite, and there's these little stars. They're part of the design." Also, you'll notice it is showing the time at the bottom here, and that's because I have switched the unit on once before. Why did I do that? And it did lock up on the GPS, and it got its time, and it's remembered the time. The reason I switched it on previously to this big moment is because I needed to line the dish up. Now that's another bit we didn't film because quite frankly that is quite tedious, waving the dish around and getting it all lined up. I knew vaguely which direction to point. It's about 22.4 I think the elevation from here, and about 144.2 I think the direction for me from here. So what I did is I took a shorter lead for the downlink out to my SDR receiver connected to my laptop, put it underneath the dish, turned it up loud and set it on the beacon frequency, and then waved the dish around, listened to the beacon, picked it up by ear, and then got my second assistant to watch the S meter on the receiver while I picked it up, and then clamped it all off. So that's how we got all that set up. And as I say, that would have been pretty boring to watch, I think. There we go. So not only has it acquired a satellite position, and it will tell us later on, we can step through the menus, I can show you, it'll tell us exactly where we are, but it's automatically found my grid square and is displaying that now on the front screen. So it knows we're in India Oscar 70 India Charlie. I mean, if you want to go all the way through, India Oscar 70 India Charlie 65. So it's very precise on where we are in the grid square. It's got the time is sorted, and we also have a lock here now, which means we can now transmit. And it is really important that you don't try and transmit until it's locked, because otherwise you will be wandering about all over the satellite. Now you step through the menu using this button here. So if I go one notch forward, it just tells us the temperature of the unit, current that it's drawing at the moment, and there's our exact positioning as far as the GPS has worked out. And this tells us what configuration we've got set up, so we can change any of these. And you notice that it's got an update firmware on there, and it has a built-in Wi-Fi access point in it. And if you want to update the firmware, you do that using your mobile phone. You connect to it through its own Wi-Fi, and you can upload new firmware software to it that way if you need to. But this is the latest version of the software that we've got there. This screen here, we've got RX on one side and TX on the other side. So these are the frequencies we're using. Actually, it's got them both the same at the moment, so that's no good. So if I press this in, I can go across to there, and I can press that, and I can now step through all the options. And actually we can go from 28 megs, 28.5, or we can have 50.5, or it's a bit quick there, 70, I'm going too fast for it, 144.5 or 432.5. So that's the one I want, 144. And if I press that, that's now set. And if I press it again, I can change the RX. Well, I don't need to, because that's what I want it to be. I want the RX going down into my shack to be on 432. So that's converting the 10 gig satellite signal, comes into the LMB, is converted down to the frequency that this works out, which is around 700 megs, I think, and then that's converting that down to the 432.5. So I'm happy with that. So we can just confirm all of those. There we are. So that's set up. RX is coming down at 432.5. Transmit is 144.5. And just so I can show you the other menu items here, and to go through the menu items, to scroll through, you just turn this knob right or left. So this screen here is telling us basically how the ground station is feeling in itself. So that's the current we're drawing, 0.63 amps. That's the voltage to it at the moment, and that is the temperature of the unit. And then if we go to the next screen, this actually shows us that even with the GPS antenna indoors here in the garage, we've acquired quite a lot of satellites there, so that's quite impressive. We're ready to go, I think. So the next thing to do is to go down into the shack and check that we're hearing the downlink coming down on 432 megs from the ground station to my shack, and then we'll try it out on transmit. So the moment of truth. Here we are in the shack, ready to fire it up. I'm going to use SDR Uno on my computer here. By the way, apologies about my desktop. It's almost as cluttered as my garage. But SDR Uno is the software that I use with my RSP1 SDR. And so the cabling that's coming down from the ground station 2 on 432 megs is coming into the shack here, into my RSP1. And hopefully, when I click on this, we will see in front of our very eyes the whole QO-100 transponder materialize. So Here we go. Let's load it up and hit play. Boom, there it is. Look at that. There we have the transponder. We can see the bottom CW beacon here. This is the experimental digital beacon, and that's the top Morse beacon. And there's also a PSK beacon right in the middle of the transponder. It used to be actually that it was this side left of this middle beacon was what was available for people to use, but it has the transponder availability has now been widened out, so both sides of the beacon are usable. Now, it is very important before you pitch up on QO-100 and start transmitting that you know what the band plan is and that you're transmitting in the right place. So I have actually got a printed copy of the band plan pinned up in front of me so I don't get it wrong. But if we just have a look at it, you can see that we've got the CW beacon at the bottom there. Then the next section is CW only. Then there's narrowband digital modes. Then there is digital modes. The narrowband ones are 500 Hertz bandwidth or below. And the digital modes, the next little section is 2700 Hertz bandwidth or below. Then we've got the SSB only section. We've got the PSK beacon in the middle. And then we've got another SSB only section. And by the way, 2.7, the maximum bandwidth that you can use. And then, as you can see, we've got mixed modes and special purposes, contest CW, and at the top, the experimental beacon and the top Morse beacon, which we'll talk about more later. Now, what I'm just going to do is I'm going to get rid of these memories at the end because I don't need those for this, and just stretch out my display here. There we are. And now we've got the whole display set up to show us the QO-100 transponder. And what I've done, and I'm sure you can do this on other SDRs as well quite easily, I can do it on SDR Uno, is create a custom band. So I've just created a band that I can click on when I'm using the SAT, which just goes from slightly below the bottom beacon and slightly above the top beacon, and gives me a nice display of the whole transponder. So how do we find where we are on this display in relation to the band plan that we just looked at? Well, DX Patrol have worked this out very well, because you will find that the last 3 digits of the transmit frequency from the satellite will match the last 3 digits of your transverted down receive frequency. So, for example, the CW beacon showing on here is on 10489 decimal 500 is here on my display 432 500. And so if we use those last 3 digits all the way along, it applies for everything. So the PSK beacon in the middle is on 10489.745, and it's here in the same place on the display. If I zoomed it in, you'd be able to see that. So we can just use those last 3 digits all the way along to see exactly where we are in the satellite and follow the band plan. So let's just have a quick look. If you have a look at the bottom beacon here, you will see that the line on my SDR display is a wiggly one. So we can see that it's actually frequency shift keying. Look, there the carrier's gone constant. Let's just tune in on it. There we go. And we will hear it. There we go, identifying itself. And the reason they changed it to FSK, because before that, apparently it was on off keying. But when you're lining up your dish, it's useful to have a constant carrier to line it up on, so you can, rather than being lined up on the shifted bit, which I am at the moment, there we go. You got that constant carrier, and that's what I used when I was lining up the dish earlier. Then what we've got going on here, there's something digital happening here in that digital section of the transponder. So you will find FT8, digital voice and other digital modes, as long as they're appropriate in terms of bandwidth. You'll hear them there. And of course, absolutely never any FM. Don't have any FM on here because it's too wide, or AM. Now this is the PSK beacon in the middle, doing its funky stuff. At the top end of the transponder, we've got the experimental beacon, and just above that there's another wiggly line. That's the top CW beacon. So we can also do the same thing in terms of finding where we are, because I know what a lot of people do on the low Earth orbiting satellites is transmit a carrier, maybe keying it off and on very quickly to find where they are on an SSB transponder. You can irritate a lot of people if you stick a carrier on here and go wandering through the transponder. You don't need to do that because, just turn that down a second. If we turn our attention to the display on my Yaesu FT857 here, we can see that the same thing applies. We can use the last 3 digits and that will pretty much tell us where we should be. So the great thing about the satellite is you never have to say, is this frequency in use? Because you can see whether it is or not. And you don't get that effect you get on HF where there could be a distant station using it that you can't hear in QSO with somebody who you will blot out when you turn up, because if there's a transmission there, you will see it. So I'm just going to set my receiver to, there we go, to 700. So 432 700 on the downlink, which would be the equivalent of 10489 700 coming down from the satellite. So if we turn our attention to my Yaesu FT857, the same thing's going to apply for the uplink to be transferred to the 2.4 gigs. We can use the last 3 digits. So 432 700 is showing there. So I need to go 144 700 here. So we should be bang on now in terms of SSB resolution when I start transmitting. I know where I'm going to come on the transponder and I should be able to hear my downlink fine and pretty precisely without waving a carrier about. The other thing is, when I'm working the low Earth orbiting satellites, if I'm working through an SSB transponder, I put headphones on and listen to my downlink. Now, it is a requirement by AMSAT DL that you do use full duplex when you're working through the QO-100 as well. But just bear in mind, it's a blooming long way from here to that geostationary satellite and back, and that means it puts quite a time delay in, as you will hear when I start transmitting. So if you try to do it with headphones on, you just would definitely sound very drunk, and you do have to sort of tune it out. So you want to hear your downlink and hear it's okay. So you've got half an ear on it, but not too loud so it puts you off. So let's give it a go and call CQ. And as I say, we should resolve quite nicely on this frequency now. And you'll hear the delay when I start transmitting. So let's give it a go. Let's turn the volume up so we can hear it. Hello CQ, hello CQ, hello CQ, hello CQ. See, we're on frequency, which is good. This is Golf 0, Foxtrot Golf X-ray. Golf 0, Foxtrot Golf X-ray, calling CQ QO-100, CQ QO-100, CQ QO-100. Golf 0, Foxtrot Golf X-ray, listening. Also, we don't want to be louder than the beacon signals. If you are louder than the beacon signals, you will get an audio alarm that tells you you're running too much power into the satellite. And these beacons are uploaded from Germany by AMSAT DL. They upload the beacons and also the system that monitors your power up and will tell you if you're too loud. Hello CQ, hello CQ, hello CQ, hello CQ. This is Golf 0, Foxtrot Golf X-ray. Golf 0, Foxtrot Golf X-ray in the southwest of the UK, calling CQ, CQ, CQ. CQ satellite, Golf 0, Foxtrot Golf X-ray, listening.
G0 Fox Golf X-ray, Oscar Hotel 5 Lima Kilo.
Ocean Henry 5 Lima Kilowatt. This is Golf 0 Foxtrot Golf X-ray returning. Very good afternoon to you. My name is Bob, located in India Oscar 70 India Charlie in the far southwest of the UK, and you're a very good signal. 5 and 9, well above the noise on the satellite, so coming in very well indeed here. From Golf 0 Foxtrot Golf X-ray.
Good afternoon. Nice to hear you and work you on QO-100. We have worked on the LEO satellite, but from my VHF location.
So we've worked on a low Earth orbiting satellite before.
Not here in the same square. So 5 by 9. My name Jussi, Juliet, Uniform, Sierra, India. Located Kilo Papa 40 Lima Foxtrot. Kilo Papa 20 Lima Foxtrot. Located in Helsinki. and I just saw that I was probably answering off-site from your frequency. So
Bang on now.
sorry about that, and glad you found me. How copy? Over.
And what I do now, I've established communications, I turn down my monitoring while I'm talking so I don't sound drunk. Oscar Hotel 5, Lima Kilo, this is Golf 0, Foxtrot Golf X-Ray returning. If I'm business juicy and you're coming in very well indeed here, very good signal into the far southwest of the UK, and fine on us having worked before on one of the low Earth orbiting satellites. So nice to meet you again. And I'm just doing a little demonstration of working on QO-100 for our online TV program called TX Factor. And we're using the DX Patrol Ground Station 2 here and testing it out for those who watch our programs so they can see how easy it is to get onto QO-100 and take advantage of this fantastic satellite. So I hope you don't mind that we're actually filming this at the moment and recording this QSO for our program, Juicy. So hopefully you're okay with that. And I think I gave you my square, India Oscar 70 India Charlie. So back to you in Helsinki. Oh, by the way, my QTH is Helston, like Hotel Echo Lima, Sierra Tango Oscar November. Oscar Hotel 5, Lima Kilo, Golf 0, Foxtrot Golf X-Ray.
Okay, fine with being in Helston and me being in Helsinki. Very fine. And no problem. This is not a video contact, so you cannot see my ugly face. So, thank you. 73. Have a nice day. Golf 0, Fox Golf X-Ray. Ocean Henry 5 Lima Kilo. Bye bye, Bob.
There we are. Straight to Helsinki via satellite. How marvellous is that? And it just is great to have a whole section of band, as he said, with no man-made noise on it. So that's another advantage if you live in an urban environment. And you've given up on those QSOs where you can sit and have a good old rag chew with somebody because the reception is spoilt by QRM or the fact you can't put up a decent antenna. And that's one thing else that I've noticed about QO-100. There's a lot of more rag chewy conversations going on. People chat and get to know people on this satellite and people all around the world that you can chat to and have a good old yak rather than 59, thanks very much, 73. I said I would tell you a bit about the experimental beacon in a moment or two because it's experimentally sending HTML pages, web pages, coming off the satellite. Let me show you. First of all, you need to download a piece of software called the AMSAT DL Multimedia HS Modem, which is quite a mouthful. And once you've downloaded that, and it's also useful for other things that you can do on the satellite, such as image transmission and so on and so forth on the narrowband transponder. But we won't go into all of that now. Let's just have a look. I've tuned this in so that you didn't have to watch me fiddling about with it. So I've got RX signal and it's synced. And you have to select the right speed in bits, which is the 7200 one. So there we are, and we've got a little tuning window that helps us tune. It's showing that it's downloading some blocks of information. Now, the first time you ever do this, it downloads an HTML file for you, and it puts it in the RX folder. So if I now click on Open RX File folder, and if I open that now, see there's a little HTML file here, and if I click on it, it's going to open in Google. Look at that. Now, this isn't coming off the internet. It's not coming from my local receiver here. These two images of the waterfall are being sent from the satellite on that beacon. So we've got the narrowband transponder activity on the left and the wideband transponder, that's the DATV transponder, on the right. And look here, the DX cluster is actually downloading before our very eyes. So it's putting that information up there. So if you were, for example, on a DX expedition somewhere where there is no internet connection, you'd still be able to have the DX cluster up there and have a look at that. And, you know, this is experimental. It's showing what could be done. And I think looking very much at the potential perhaps for emergency comms using a beacon like this. And as it says at the top of the screen here, all information shown here transferred via QO-100. Internet is not used anywhere. I hope you've enjoyed our introduction to QO-100 operating and our look at the DX Patrol Ground Station 2, which I found a really easy way for me to get into using this satellite, because there's not a lot of wiring up this and wiring up that. It's all there in the one box. And as you saw, I just needed the RF cables down into the shack for TX up and the downlink from the ground station itself, then 2 LMB cables up to the LMB and one 2.4 gigs cable up to the Helix antenna, and we were in business. So it's very straightforward to set up, and it does all the things you want it to do. It has the GPS lock, and you know you're going to be stable in terms of frequency, and just a really high quality bit of kit. And people have been saying as I've worked them, you know, that we're a good strong signal into the satellite, not too strong, good audio, so all working very well indeed. One thing that people might say is, well, it's quite an expensive way of getting onto QO-100 to buy that all in one box. My previous experience with satellites has been with the LEO satellites, and so I had an azimuth elevation rotator, some expensive antennas on that, and some masthead amps. And by the time you add all that up, you're going to be way ahead of what the DX Patrol ground station would cost you. So you can weigh it up as a decision. I mean, for me, what happened was my azimuth elevation rotator packed up. It's been up there a long time. I'm not sure I'm ever going to put it back up again, to be honest, because I'm getting great satellite activity here on QO-100, and I have got a couple of helical antennas, some QFH antennas that I put up for 70 SEMS and for 2 meters that I am using with the LEOs with reasonable success. So I think I'm happy that this is where my focus would be, to get on QO-100. And the other thing is, of course, we can unplug it from where it is on top of my fridge there, and using that small dish you saw earlier, I can take it out portable as well, which I plan to do in the summer.